you. We're gonna, our goal is to be graphing trigonometric functions in this section. And so, in order to do that, we need to take a step back, and you learned some of this here in the Algebra 2 days. But I want to refresh memories and get us all to the same spot. Okay? So if I'm talking specifically about the sine function, okay, y equals the sine of x, where x is in radians. Okay? So a couple of observations about this graph. So first off, if you'll notice, the domain of this graph is all real numbers. There's not a value of an angle that I can't put into sine and get out an answer. Okay? Right? I can put any value for any angle into sine and get out an answer. So my domain is all real numbers. Okay? You learned way back whenever that the biggest that the sine gets, sine is y's on the unit circle, the biggest that it gets is positive 1. Okay? We talked about that in the obviosities. So the high of this function would be positive 1. In the obviosities, we learned that the lowest value of sine is negative 1. Which means that sine will always be in that range of values, from negative 1 to positive 1. Okay. The middle of those two, so if I'm on high, I'm at 1. If I'm down low, I'm at negative 1. The middle of those two, that's 0. Yeah. Which means then that the amplitude is 1. And today we're going to talk more about amplitude. So I'll explain what amplitude means in a little bit. But the amplitude of this function is 1. Okay. Now the next one is start, end, and period. Okay. So this function, let me go in the purple because it's distinctive. Okay. This function starts at 0. Okay. Starts at 0. Goes up, comes back down to 0. But that's not the same as where it started. So we're going to keep going through, because when it started, the function was increasing. Okay, the function was going up, so it was increasing. Here, it's going down, so that's not at the same spot. But then when we come back to this point, now again, it's back on the increasing, so that's where it's going to end. So it starts at 0, and it ends at 2 pi. The horizontal distance that takes on, or that it takes to get from the start to the end, that's what's called the period. Okay? And then it's also, that's how many times that, excuse me, or how long it takes to get to do another lap, another wave. So it would also take 2 pi in this case to get a second wave. And then at 6 pi, we would have a third wave. And at 8 pi, we would end our fourth wave, and so on and so forth. Okay? And these types of things, these, what is it, 2, 4, 6, 9, these 9 different things, we're going to do that almost on every single graph that we do in this when we're graphing stuff, because it helps us with graphing the function. Okay? So then for cosine, all of those values are actually the same. Okay? The domain of cosine is still all real numbers. Cosine goes all the way up to positive 1, goes all the way down to negative 1, which means that cosine has a range from negative 1 to positive 1. Still puts the middle of cosine at 0. The amplitude is still 1. Cosine now starts at the top, then goes down, and then comes back up, and ends at the top. So it starts at 0, it ends at 2 pi, which means that the period, the horizontal distance between those two input values, is 2 pi. Now, if things were nice and easy, that would be the only thing that we'd have to do. Okay? But that's not the case, because what we're gearing up towards, our end goal, is we're going to try and curve fit a sine or a cosine curve onto a certain set of data. Okay? Because the data might be periodic in something. Okay? Temperature is a periodic function. Okay? Depth of the ocean at a pier is a periodic function with tides and things of that nature. Okay? So we have to translate this graph or transform this graph in different ways. Okay? And so what we're going to do is we are going to talk about A values. That's going to be our amplitudes. We're going to talk about B values. That's going to adjust our periods. We're going to talk about C values, which are going to adjust where we start the function. And we're going to talk about D values, which shift our graph vertically. Okay? And we're going to break these down over the course of the rest of the semester and maybe then some, so that we can get to that point where we can curve fit, we can put a curve of best fit onto a certain set of data. Now, in terms of graphing, we are only going to graph the first lap wave. So we're going to start it for today, like we're going to start at 0, and we're going to end it at 2 pi. Yes, it goes on forever in both directions, because the domain is always going to be all real numbers. But we're only going to cut out just that first lap, or that first lap wave. Okay, so one wave. So in this case here, we'll go in this one. So in this case, it's for cosine, that's our first lap wave. And for sine, that's our first lap wave. Okay. So we're only going to do one wave today. Okay? So, let's talk the first one. The first one is amplitude. Okay? Amplitude is the distance from the middle to the top, or the high point, as we might call it, okay? Or from the middle to the low, or to the bottom. That's what's called the amplitude. If you were an oceanographer, okay, it would be the height of a wave. So what they're saying is when you hear that there's 8-foot waves, okay, that's the distance from the middle to the top. The top of the wave is 8 feet. Okay? All right. Now, amplitude affects 3 things on our graph. Okay? So it has influence over the high of the graph. It has influence over the low of the graph. And it has influence over the graph's range. That's it. That's all it affects. It doesn't affect where it starts, where it ends, the period. It just affects how high up you got to go in your graph, how far down you got to go in your graph. Okay? All right? So, let's do it. Let's do 1, or 2, or 4, or 15. Because we can. Okay? So, we are going to ask you those 9 questions almost every single time. Okay? Just because it acts as a good starting point for you to think about how to put this onto or how to make a graph of it. Okay? And I'm going to show you 2 different ways that are both exactly the same, just in a little different order, to graph these functions. Okay? So, first off, the domain will always be all real numbers. Okay? Always. Okay? Now, normal sine here, if I went normal sine, would have a maximum value of 1 and a minimum value of -1. Agree? Normal sine would. Well, if I multiply that by 2, now my maximum, my high value, is going to be 2, and my minimum is going to be -2. Which that tells me my range then. My range is going to be from -2 to +2. Which puts my middle at 0, all because my amplitude is 2. My amplitude is my A value right there. Until we get into B values and C values, which we might get to tomorrow, okay? Until we get into that, we are always going to start at 0. We're always going to end at 2 pi, which means that our period is always going to be 2 pi. Until we get B values and C values, because that affects that stuff. Okay? So, I promised you 2 different ways to graph these functions. One way to graph these functions is to start with a sine curve. You graphed some sine curves before in Algebra 2. You did some yesterday. Sine starts in the middle, goes up, comes back to the middle, goes down, and ends in the middle. Okay? So one way to graph these functions is to start with the curve. And then you have to go on to that and label your axes. And you need 8 labels on your axes. So you would need 3 vertical labels: your high, your middle, and your low. You would need 5 horizontal: your start, your end, and then 3 middles. Okay? So what's half the distance from 0 to 2 pi? Or what's half of that distance? Pi. So my middle here is at pi. What's half the distance from 0 to pi? Pi over 2. What's half the distance from pi to 2 pi? 3 pi over 2. And that, ladies and gentlemen, is a wonderful graph of the function 2 times the sine of x. Okay. Now there's one thing that we haven't talked about yet. What happens if my a value is negative? For instance, what happens if my a value is negative? Well, move that down a little bit. If my a value is negative, my graph is going to flip. My a value is negative, my graph is going to flip. So if I have a positive a value, that would be my sine curve, right? Start in the middle, end in the middle. If I have a positive a value, my cosine curve would start at high, end on high. If I have a negative a value, I'm going to go down first for sine instead of going up first, but I still start in the middle and end in the middle. For cosine, my negative a value, I would start below, or start at the low, and end at the low. My graph literally just flips over. Okay. So, with that being said, my amplitude, my a value, right there, or I shouldn't say my amplitude, my a value is -3, which means my amplitude is 3. Amplitude is a distance, so it's always positive. I had no other shifts, so that puts my high to 3, my low to -3, my middle at 0, which means my range is that. Domain, as always, all real numbers. Started at 0, ended at 2 pi, which gives me a period of 2 pi. Okay. First way we drew it with starting with the curve and then fitting the labels onto it. Second way is we start with the labels and we fit the curve onto it. So we have a flipped over cosine curve, so it's going to start at the bottom, go to the middle, to the top, back to the middle, and then end at the bottom. Questions, comments, concerns, clarifications, rude comments. None? Awesome sauce. Graph that one for me, please. Oh, let's see. Well, domain, of course, we know that. That's always all real numbers. We got cosine value with an a value of a half. So my amplitude is 1/2, which means my high is going to be at 1/2, low at -1/2, middle at 0. Love it. I like starting up, down. Ooh, nope, don't like it. I went too far down. See, sometimes I gotta have my marks. Close enough. Now, the question is, Bessie, or did you have an actual question? Okay. The question I was going to say is, Linz, what if we don't label our axes? Exactly. Cordy's giving you the thumbs down. Okay. So,
What if we just put like pi with 2 and 2 pi?
Cordy, what do we want? Thumbs down. Because it's not always going to just be at those spots. You know what I mean? Sometimes we're going to shift, later on, we're going to have a horizontal shift. And so then we're going to have to adjust all of those spots. Yep. Okay? Go for it. We got 6 minutes to do 2 graphs. 3 minutes too long. Yes? What's wrong? Oh, okay. One more? What's wrong? Oh, you got a question on this one, guy?
No.
Oh, okay. Happens. Oh, maybe that was our last one. Oh, that was our last one. Look at that. I thought there was 2 more. What a happy surprise, Chris. Okay. All right. So amplitude A is the vertical stretch, if you will, almost. The vertical stretch or the vertical compacting of